Let's look at the Greek Orthodox Easter, fixed by the Julian calendar, which is 13 days behind our Gregorian calendar. Why this difference? The Earth's annual journey around the Sun lasts 365¼ days. So every 4 years, we have to add a day, the 29th of February, to keep in step with the real year. The Julian calendar was introduced by Julius Caesar. It's only out by 2/3 of a day in a century, less than 10 minutes a year. Even so, after 16 centuries, we'd built up an extra 10 days. So, Pope Gregory XIII removed these 10 days. And to stop the same lag building up again, he decided not to add a day in the last year of each century. Today we still use the Gregorian calendar. However, in countries where they practiced the Orthodox religion and didn't obey the Pope, they kept the days he'd skipped, so they were 10 days behind. Then in 1700, 1800, and 1900, the last years of 3 centuries, they got 3 more days, adding up to a 13-day difference. The calendars are different because people work differently with time. In February, we could see Orion due south at around 9 p.m. It's easy to recognize with its head, 2 hands, 2 feet, and belt. But if we look tonight, Orion has gone from the south. To find it, we have to look to the right, southwest. Orion is a useful guide to help us imagine the Earth's journey. In 1 year, the Earth moves around the Sun, a complete circle of 360 degrees, so 1 degree a day. Each night at the same time, we look 1 degree further left and see the stars have slipped 1 degree further right. The Earth continues on its way. 2 months have passed. To find Orion, we have to look right to the southwest. And in 2 months, when the Earth has continued on its orbit, Orion will be behind the Sun. Naturally, we won't see it. In 2 months, Orion has moved to the right. But in reality, Orion hasn't moved. It's the Earth which is carried on around the Sun. When the Hale-Bopp comet passed, it showed us that the solar system wasn't limited to planets. Unknown bodies can appear at any time, such as new comets or asteroids. Tiny planets make up the asteroid belt between the orbits of Mars and Jupiter. How did they form? For a long time, we thought the asteroids were the remains of a planet, which was destroyed in a collision. Now we think that we have to look back to when the solar system was created. The asteroids are probably the remains of the interstellar matter which didn't stick to any planet, floating between Mars and Jupiter. Thousands of asteroids circle on tangled off-center orbits. You could say they're the reckless drivers of space. The risk of being hit by a comet is extremely small. Collision with an asteroid is a greater danger. There are asteroids of every size. Little meteors which flame in the atmosphere and burn up without reaching the ground. And meteorites, pebble-sized, which fall to Earth in their thousands without ever hitting anyone. A building-sized asteroid fell on Siberia in 1908, destroying 2,000 square kilometers of forest. But there are even bigger asteroids than that, the size of a mountain or an island. Every day, our increasingly sophisticated radar is discovering new Earth-crossing asteroids. Asteroids that cross our orbit. The asteroid Gaspra is the size of the island of Jersey. If an asteroid that big hit us, all life would be wiped out on Earth. If we saw an Earth-crossing asteroid approaching on a collision course, we'd have to intercept it with a rocket to change its direction. But for the moment, there's nothing threatening on the radar screens of our Spaceship Earth. Scientists are very interested in comets and asteroids. Several space probes are heading through space to explore them. The asteroids could be more useful than the planets in revealing the origins of our solar system. The planets formed by attracting more and more interstellar matter. Over billions of years, this matter has changed a lot. It's been compressed, heated, melted, and blasted out of volcanoes. On Earth, original matter is forever being twisted and changed by the atmosphere, water, and erosion. But the asteroids are intact. They have no atmosphere, no erosion, no pressure. They're the untouched remains of the raw material of the solar system. They're an ideal field of exploration to discover more about the origins of matter, about our origins, because we're made of matter too.